First, let's talk about what is normal distribution. So whenever you're looking at, for example, population, and if the population is large enough, and if it is random, it is generally create a bell curve. When you're thinking about a 10-year-old, what would be the height of a 10-year-old? So imagine, like, for example, 120 centimeter is going to be the height of a 10-year-old. That doesn't mean if somebody's 150 centimeter, they're not going to be a 10-year-old. You might have a taller 10-year-old, or you might have a shorter 10-year-old. The reason you can identify that is because of the normal distribution. Because when you're looking at the kid and then you say, oh, she's taller than what a 10-year-old should look like, or oh, she's shorter than what a 10-year-old should look like. So that just shows that you already have a concept of normal distribution, or the bell curve, in your mind. What K-mean and Demystified was doing, it would say you're either 100% part of this cluster, or you're either 100% not part of this cluster. There's no in between. There's no like multiple cluster for one point and things like that is not happening. They are called hard clustering. Visualize your data set. See how your clusters look like. Now you can see the clusters very clearly, and also they are spherical shape. The best idea is to just go with K. And then if you have like a data structure that are more, it seems like they have more complicated relationship with each other. If you see like patterns that there might be like clusters mixing with each other, and then they are more like spread, like elliptical instead of spherical, your best bet is to use GMM, criminal profiling. It's a very interesting thing. So you can, for example, describe the crime that happened, and where it happened, how it happened, all of these things. And then when you start clustering these into different clusters, and using something powerful like GMM that can capture the normal distribution, and not only that, but also can give scores to each data point, probability of each data point to be part of different clusters. So that is very powerful for a complex task like criminal profiling, which is dealing with human behavior. For example, you describe how the crime scene looks like, and then all of the factors that you have, you will describe all of those factors that you have, and then it will look to see which one of these clusters these will fit in. And then, for example, it will say the person that you're looking for, he probably it's a male, he will probably weighs this much and will be a muscular person. And it might even go deeper, as in say, for example, what type of behavior he might show, if he's a dangerous person or not. You can say 100% of people who are muscular and over 185 centimeter are serial killer. But then when you're talking about the probabilities and say, okay, this is the crime scene, the chances is that you're looking for this type of person. Imagine that your cluster shows that this person that you're looking for, this criminal that you're looking for, is probably hiding in a washroom in Subway. That does not mean that if you're going to the washrooms in Subway, you're gonna find the person that you're looking for. But it's saying that the chances of him being there is more than him being in like a party in Japan. Just to recap, GMM is a clustering technique. It does soft clustering, so that basically means it doesn't assign only to one cluster. It doesn't say it's 100% this cluster or it's not this cluster. So it does soft clustering, and then it is in the form of a normal distribution, which goes hand in hand with probability, because you don't just end it, you don't just cut it off. You're gradually going down, you're gradually decreasing